Okay, now that we have the basics of polynomial long division down, let's see some unusual things that might happen, or some things that might not be quite the way that you would expect them. So let's look at a problem where we have some omitted terms. Let's look at something like, let's say I'm going to take 8a cubed plus 4, and I'm going to divide it by 2a plus 1. And in this numerator, it's a degree 3 polynomial, but I'm missing the a squared term and the a term, right? So I'm missing some terms. Well, in long division, if I was going to divide 1004 divided by, say, 21, I don't just write in the 1 and the 4 there. I have placeholder values, right? And in the last video, I talked about these being placeholders. In the last video, I talked about the degree of the term being, in some sense, what position in the number you were. And we need those just like we need zeros in this long division. So how we set this thing up is we're going to write 2a plus 1, and we're going to divide it by 8a cubed, but I need a placeholder for the a squareds. So I'm going to put in 0 a squareds. I'm going to put in 0 a's, and I'm going to put in a plus 4. Okay, so now I have all of my placeholders and all of my positions where they need to be, and we can actually perform this long division. If you don't keep those placeholders there, in the term where you multiply this by this number up here, you're going to end up with 1 times some a squared thing, and you just won't have any place to put it. So we want those there for organizational stuff. So how many times does 2a go into 8a squared, or 8a cubed? 4a squared times. So now I do the multiplication. I get 8a cubed plus 4a squared, and I subtract that off, and I'm left with 0 there and a minus 4a squared there. I've got still a plus 0a, and I've got a plus 4. Now we do the next one. How many times does 2a go into negative 4a squared? Well, that's minus 2a times. So now I multiply, I get minus 4a squared, and I get a minus 2a. I subtract those off. Negative 4a squared minus a negative 4a squared is 0. 0 minus a negative 2a is a positive 2a, and I get a plus 4 there. And then how many times does 2a go into 2a? It goes in there 1 time, so plus 1, 2a plus 1. This time when I subtract stuff off, I'm left with a 3. And that was my last position. And 3, if I try to take 3 divided by 2a to figure out what the next number is, I don't really go anywhere. I can't make this division into a nice number. It's not a number, it's got variables in the denominator. So this is my remainder. This is my remainder. We hadn't seen any with remainders before. Okay, so then I'll put this remainder of 3 here. So let's write this out. Remember last time we talked a little bit about how we would write these things. I'm going to write it as 8a cubed plus 4 over 2a plus 1. This is equal to, well, it's the quotient, and the quotient is 4a squared minus 2a plus 1 plus the remainder, which is 3, divided by the divisor, 2a plus 1. Okay, so the divisor has, this is my quotient, this is my remainder, this is my divisor. If we look at this, the remainder should always be a smaller degree value than the divisor. Okay, so if I was dividing by a quadratic, the remainder could be a single term, or like a 1 degree, a linear term, right? If this had a degree 2, this could have degree up to 1. It could still be degree 0. If this was degree 7, the remainder could be anything degree 6, degree 5, degree 4, and so on. Just like how the remainder has to be smaller than the number that you're dividing by, in polynomial stuff, the remainder has to have a smaller degree than the polynomial you're dividing by. Okay, let's see another one here quick. Sometimes things might be out of order. Let's look at this one. So the book says we're going to divide 3x squared minus 7x plus 4, and we're going to put that into 7x minus 1 plus 6x cubed minus 5x squared. Okay, there's not any missing terms. I've got degree 3, degree 2, degree 1, degree 0, so that's good, but they're in a weird order, right? We usually want to write degree 3 first, so we're going to switch stuff around. We're going to move these over that way, and we're going to move these over that way. We're going to rewrite this so that it's in the correct order to divide by. So I got 3x squared minus 7x plus 4, and I'm going to divide that into my degree 3 is the highest term, so 6x cubed, then the degree 2 minus 5x squared, then the degree 1 plus 7x, then the degree 0 minus 1. Okay, so that goes into there. And now I'm still going to take leading term divided by leading term. So I've got the 6x cubed divided by 3x squared. That's going to be, most of these are going to cancel. The 6 and the 3 are going to turn into a 2x. So I get to put a 2x there. So I've formed 2x groups. The groups are of this size. I'm going to multiply 2x times all of this stuff and subtract it off. So I get 6x cubed, which is good because those two numbers should always match up perfectly because we did this division so that they would over there. Minus 14x squared plus 8x, right? This is the minus 14, this is the plus 8. Okay, we're going to subtract that off. I get 0. Negative 5 minus a negative 14 turns into a positive 9x squared. 7 minus 8 is minus 1x, and then I've got a minus 1. Okay, 3x squared goes into 9x squared 3 times, so this is going to be a plus 3. And I get 9x squared. I get minus 21x. I get plus 12. We're going to take that away. We get 0. Minus 1 minus a negative 21 is 20x. And minus 1 minus a 12 is minus 13. Okay. 3x squared does not go into 20x, right? If I try and cancel this, I'd be left with a variable in the denominator, right? The x would cancel, I'd be left with an x in the denominator. I don't want x's in the denominator. And like I was saying just a little bit ago, this whole thing is going to be my remainder. It's a smaller degree than the divisor. Okay, so let's write this out. What I get is that 6x cubed minus 5x squared plus 7x minus 1 divided by 3x squared minus 7x plus 4. That is equal to 2x plus 3 plus my remainder, 20x minus 13, divided by the divisor, 3x squared minus 7x plus 4. Okay, so I've got quotient, remainder, divisor, and that's my solution. Okay, now you guys should be experts at polynomial long division. We'll see you in chapter 7.